In this video, we will discuss one of the most common code smells, deep nesting. I will first cause the issue and then show you a few techniques to mitigate it. This is the domain model we will use, a book author with only the first and last name, and a book model with 0 or more authors. The technical request is to write a simple method that will take a sequence of books and return one mentioning the hinted word. Return the first book that contains the hint in its title or any author's first or last name. Return null if no such book was found or the hint was empty. As I said already, I will first cause the problem. I will apply the coding style that favors deep nesting. Look at my first step, checking if the hint is a non-empty string. If it is not, the request is to quit searching, so I return null in the if block. I haven't even started working and already have one nesting level. Let's speed this up now. Sanitize input. Then start looking for the matching book. Loop through the books. Check if the title contains the hint. If we are still searching, then remember the current book. We must also look into the authors. Compare each author's first and last name against the search phrase. Repeat the protocol and optionally set the overall result. Eventually return the book we found, or null if nobody has set it to non-null so far. Does this resemble your coding style? Is deep code nesting your habit? Do you notice the problems that habit causes? Let me point out a few of them. You must switch to a different level of abstractness in your head each time your eye traverses from one line of code to another. What is this string comparison instruction doing in the middle of the looping construct? Worse yet, the statements at deep nesting levels communicate and affect each other long distance. That will sometimes cause subtle bugs. The overall structure of this code requires a lot of thinking, even when one glances over it. Life would be so much easier if we could turn this method into a straight sequence of instructions. And we can. Look at this if block, for example. It sets the reference only if it is null but leaves it intact if it is not. The null coalescing operator does precisely that. One nesting level down. Be aware that the nesting will still be there. But it is the compiler's problem now, not ours. The same case above, and I have started feeling better already. The second technique I want to show you is about changing the algorithm. Consider a different approach that dismisses nesting and branching altogether if possible. For instance, why iterate through the rest of the books if we have already found the answer? Returning from the middle of the loop is the most efficient way to cut the deeply nested operation. Repeat the same pattern here too. This idea can simplify the method. For instance, if we survive through the loops, then the search failed. Return null unconditionally and remove this variable. You can see that long-distance communication between deeply nested ifs is now gone. One problem less at the expense of introducing a brand new code smell. You must have heard that returning from the middle can be harmful. If that is your fear, let me give you a remedy. Returning from the middle is much less dangerous in an extremely short method. The way to safety is to reduce nesting further until the method becomes so simple that we can dismiss any possibility of a bug. We do that by understanding complex parts of code. I will start doing proper refactoring at this point. That will cause significant portions of code to move around. The result will be magnificent, I promise. But you must be focused through the process to figure it out. Feel free to subscribe to my channel and watch other videos I have made. More goodies are awaiting you on my Patreon page. I invite you to visit me there. Now let's go back to reducing needless nesting in this code. What is this Boolean test? It repeats 3 times, which is a code smell in its own right. If I moved this comparison to a separate Boolean method, I could expect that to help me reduce nesting later. My instinct tells me that extracting methods always helps see the essence. This is what I'm trying to tell you. Now that I have extracted comparisons at a string level, I can extract a higher level comparison, this time at the level of an entire author. Do you know what this block is? It has 2 nesting levels, but all it does is check whether any author satisfies the Boolean test. The time is to pull the heavy axe and use a link. The link any operator will apply the Boolean test, reducing the nesting by 1 level. But why stop here? This entire expression now operates at a different abstractness level. Why not extract that into a separate method and only call it here? That finally opens up the possibility of reducing nesting. You can often join subsequent branching instructions into one. Why is this important? You must have learned it already. The Boolean test speaks its own language. Extract a Boolean method and confine that language inside of it. That brings us to the pinnacle of the entire refactoring. Look at this block. What is it? You have seen how effective LINQ is in combining a loop with a Boolean test. This is an excellent example because this entire block is nothing but a call to the LINQ first or default operator. Redefining a variable was yet another code smell which I tolerated all this time. I can get rid of it now by trimming the hint in line. Look at my code now. Only 1 nesting level has remained. I cannot remove this one because it depends on the input argument. Since I do not know the value the caller will pass, I must branch. But even in this situation I have a few options left. One option is to apply a guard clause. Test the input and quit preemptively if the rest of the method does not apply. Another approach is to turn the entire method into a pattern matching expression. This is one pattern, the empty hint. The rest is the other pattern, any other hint. Why return then? Turn into the expression-bodied method and refactoring is over. Where have all the nestings gone? I can almost hear myself singing that. There are 3 principal sources of nesting in code. Any standalone branching such as input parameter validation fits pattern matching nicely in modern C#. It will always be 1 nesting level. Any looping is a likely candidate for LINQ reducing to 0 nesting. Any filtering is a likely candidate for a LINQ predicate, which also reduces it to 0 nesting. And there is the bonus you will always enjoy after a refactoring of this kind. Every method in the final solution will only do one thing, reinforcing the single responsibility principle in your code. And every method will operate at 1 level of abstractness, reducing the cognitive pressure it imposes on anyone reading your code. This final code is doing everything that initial code did. But I'm sure you will agree that it is much more pleasant to the eye and not to forget bug-free.